Hi, everybody. I just wanted to say that I hope you had a great time collecting your data on Thursday in the morning and the afternoon. I hope you got all of your data. Please remember to send your raw data sets to me by, let's say, Friday afternoon, and I will send them back to you with feedback. If everything is okay, then the feedback will be leave as is. If it needs to be changed, then I'll ask you to make specific changes. The slides to follow and the video that accompanies it provide great detail with regard to definitions that we need to move forward and end our class. So please find a way to memorize these ideas. You need to know the differences and you need to click in with what these ideas are. So on this slide, our title slide today, Understanding Variables, I just want you to see the number of variables that students in my classes have actually collected. These are from several years of data collection in the new lab, in the new building. At any rate, you can see here in the top left, they're testing squat time, and they were also in the back judging the quality of the squat and whether or not there were errors involved. Over here, they were looking at music and typing and whether or not typing made a difference or was interfered with when, in fact, you were listening to different types of music. Over here, you could see that the students were looking at plank time, how long a person could hold the plank. And in this slide here, they were looking at weight and balance and how people were actually able to manage the weight while balancing on one foot. And finally, you can see here an experiment where they were trying to create distraction while people were throwing free throws. So what is a variable? A variable is determined by the characteristics that they measure, and they're defined by experimenters. Remember, we looked in the literature to find what researchers are measuring and how they're defining what to measure and how to measure it. Variables have to be defined in two ways. They're defined conceptually and they're defined operationally. Conceptually means that there's a knowledge base behind it. What does it mean to be fit? And operationally means how will you measure it? How will you operationalize that variable? So as an example, for fitness, we know there are 5 components. They are body composition, the pull-up or flexed arm hang, the 1 mile run or the pacer run, the measure of sit-ups, and finally the sit and reach to measure flexibility or a range of motion. So you can see that the same variable can be defined in 2 ways, both conceptually and operationally. Remember that in our class, we're talking about quantitative statistics. To be quantifiable, a variable has to have a minimum of 2 levels. When a variable has 2 levels, we refer to that as a dichotomous variable. A dichotomous variable would be a categorical variable or a nominal variable. It also means that that variable is binary. In other words, it has 2 levels to it. We could also have a trichotomous variable or a variable that has 4 levels, but we also know that continuous variables theoretically have an infinite number of variables, an infinite number of levels that could be measured, and also as you make that measure more sensitive, then it becomes more and more and more infinite. So in the next several slides, we are actually going to be looking at levels of measurement, the independent and dependent variables and what that means. what it means to be a between subject and a within subject variable, that's also referred to as a repeated measure, and also what it means to be an assigned or active independent variable. So we've already covered the levels of measurement. I'm not going to go over these again, but based upon your test responses, I would say that you need to go over these again and make sure that you understand the differences between nominal, ordinal, interval, and ratio. Again, we're going to be using these as the basis for our decision making when we actually do our statistics selection. So I expect that you'll know what nominal, ordinal, interval, and ratio are before we're moving on. So we've actually looked at an independent variable in one of the analyses that we did when we disaggregated the data in SPSS, and we were looking at the difference between male and female means. We actually were looking at the variable sex with 2 levels as an independent variable. If you remember, we put that in the grouping variable or the independent variable. The independent variable is defined as the measure that is manipulated by the experimenter. So in experimental research, we're looking at cause and effect. And when you have manipulation, as you have in an independent variable, that would be the cause. Examples of independent variables might be things like, I might manipulate the type of instruction that you have. So if I were to look at the final exams of students that took my Kin 175 class in the regular session, and those students who take my Kin 175 class in the summer session would represent massed practice. Happens in 9 days. It's massed, long days. Distributed practice would be, I have 2 lectures a week, 1 hour each lecture. It's distributed across 16 weeks. It's a much easier schedule, in a sense, to deal with. So I'm manipulating the conditions of massed and distributed practice, and I would assign subjects to either one of those groups. One of the problems with this study that I want you to think about is during the regular semester, you're balancing a lot of coursework. In the summer, you're usually just taking one class and you're focusing on that one class. So the comparison here of massed and distributed is not really a very good comparison because we have not control for all the conditions that go along with the teaching of the massed and the distributed and where the students come in to those classes. I might also look at a 10-week exercise program. So I would assign subjects to either an aerobic group, an anaerobic group, or a combination group, so that the aerobic group might do running for 10 weeks, and the anaerobic group might do weightlifting for 10 weeks. And the combination group is going to do an equal amount of exercise to the aerobic and the anaerobic groups, but they're going to do a combination of running and lifting. In sport management, you might be interested in looking at an independent variable such as marketing strategy. Marketing strategy could come in 2 forms. It could be a direct marketing strategy where I say, hello, I represent the SAP Arena. I would like to sell you tickets tonight to all of the home games. I'd like for you to be a season ticket holder, blah, blah, blah. Or indirect marketing, where I market this not in a direct way, but in a passive way, so that people may pay attention to the marketing or they may not pay attention to the marketing. And I would look to see which of these marketing effects is the best. And then the last one is something that you might be interested in, athletic training or physical therapy, would be the type of stretch that you engage in with your clients. So you could do a passive stretch, or you could do a passive stretch plus a tool assist. There are many tools that are used in athletic training to increase the length of the muscle fiber and therefore increase stretch. And then compare this to a control group. What does the control group do? The control group doesn't do anything. You've all heard about a placebo effect. Well, let's say in movement kinds of studies, the control group just gets no treatment. The dependent variable in research is the measure of the effect of whatever that manipulation is. So I manipulate the conditions of practice, massed and distributed, and I want to see what those conditions of practice, the effect of those conditions of practice on the outcome, which would be the final exam. The final exam would be the dependent variable. Some other examples of dependent variables might be reaction time. I might also measure VO2 max. I could measure in sport management how much the audience participates in my activities. In other words, when they start throwing t-shirts, how much does the audience actually get involved? Is it a good thing to do? Do they enjoy it? Do they like it? Will they come back for more? And also measuring revenue in dollars in a fitness center or in your own gym. Is it worth maintaining the gym? These are all great measures of the effect. Now, I want you to notice that all of the examples that I gave you here are continuous. So the dependent variable that we're looking for, we want to be continuous. The independent variable that we're looking for is usually, or sometimes continuous, but sometimes categorical. I want you to think now that an independent variable in one experiment could be a dependent variable in another experiment, or a dependent variable in one experiment could be an independent variable in another experiment. It really depends upon the design of the experiment and how that will affect what the independent manipulation is and what the measure of the effect is. See if you could think of an independent variable in your experiment and a dependent variable in your experiment that you're doing for class. The terms between subject and within subject variables refers to the independent variables. In other words, how are people assigned to the various treatment conditions? How are they assigned to the particular groups or the manipulations that they're going to have? In a between subject variable, participants only receive one treatment or another, but not all treatments. So in a between subject design, you would either be in the masked group or the distributed group, but not both groups. In a within subject variable, that also is called a repeated measure, participants receive all of the treatments. Things like trials or conditions or tasks are generally identified as within subject variables. Active and assigned independent variables means that when the independent variable is active, it means that the experimenter, through random assignment or some other acceptable sampling procedure, places the subjects into the groups. I want you to think about my example of mass versus distributed. I said I would compare regular semester 16-week students for the distributed group to the massed group, which would be a summer group for 5 weeks, twice a week, massive hours that we spend together. It would not be possible for me to assign subjects to these groups for a real experimental design. Rather, what I want you to see is that when a subject comes to the experiment already possessing the characteristic, in other words, I don't have the opportunity to assign, or let me say, to actively give a group to the subject. Rather, the subject comes with the group assignment already. That's called an assigned independent variable. In experimental design, a pure experimental design means that all of the independent variables are actively assigned by the experimenter. Subjects are randomly assigned to the groups, again, or some other sampling procedure. In an assigned independent variable, there may be differences between those who take regular session classes and those who take summer classes. Since summer classes are accelerated classes, maybe only good students take summer classes. So now I finally want to talk about what counterbalancing is. Counterbalancing means that when you have an independent variable or a repeated measure, which we call a within subjects variable, the order of conditions should be counterbalanced. What that means is that you're controlling for the treatment effect or other possible effects such as a fatigue effect, a boredom effect, a learning effect, and a practice effect. Remember that in a repeated measure, the subject is getting more than one treatment. So by counterbalancing, I'm making sure that I look at the order effect. Counterbalancing helps a researcher to answer the question, does it make a difference if the subject has treatment A first or treatment B first? You could even have a treatment C, and you'll see that in the next slide. In counterbalancing, we use something called a Latin square design. In the Latin square design, I want you to notice in this example, I have 3 different tasks. Task 1, Task 2, and Task 3. I also have 3 different orders represented. So Order 1 gets Task 1, Task 2, Task 3. Order 2 gets Task 2, Task 3, Task 1. And Order 3 gets Task 3, Task 1, Task 2. You can see that there's a variation in the order with which they receive the tasks. So you can see that every order is not represented in this Latin square design. Rather, what you see is that each task or condition is listed at least once in every position of the order. So what I want you to notice is task A is listed in position 1, position 2, position 3. Task B is listed in position 1, position 2, and position 3. And task C is listed in position 1, position 2, and position 3. All I've done is rotate the first task to the last task in each of the orders. Notice that I've met the conditions of counterbalancing using a Latin square design in this example here in the table on the slide. So for our last 2 slides today, we're going to talk about and introduce the concept of probability with regard to how it's used in statistics. Probability statements provide descriptions about the relative power. Power means the reproducibility or the repeatability of something. Sometimes probability statements include chance, almost always include chance. The obverse of probability, of power, is chance. Chance is what is unexplainable and is sometimes referred to as noise. So I just wanted to give you an example of chance. My friends make fun of me when they travel with me because I like to get to the airport very early. So my friend Linda actually calls me up the night before we leave and she says, "Have you left for the airport yet?" Of course I have not, but she is just joking around with me. At any rate, I went to the airport one day to SFO into the new terminal, and I look down the terminal and I see Brian Mendoza. Brian was a former advisee of mine. It was just by chance that I met Brian, and I screamed across the traffic and I said, "Hey, Brian Mendoza." And he came over and we talked, and this is going back several years now, and I still have a relationship that is ongoing with Brian Mendoza. That was a chance meeting. It wasn't planned. It wouldn't be reproduced. Tomorrow I'm leaving for the airport. I don't think I'm going to meet Brian Mendoza there. But in fact, if I were traveling with Brian Mendoza, I would say to him, "Brian, TSA is really taxed right now. They've reduced the number of TSA agents, and it's going to be harder to get through the security line. And so I want to be at the airport 3 hours before, and so that I don't have to be nervous about you, I want you to be at the airport 3 hours before with me." I am increasing the power or the reproducibility, the repeatability that Brian will be at the airport. Now, certain things could happen. God forbid he gets into an accident. Maybe there's a lot of traffic. Those are the things that create noise. Those are the things that are unexplainable. But essentially, I am trying to make sure that he is 3 hours early for the airport. Not like when I meet him by chance, which is just by chance. So I want you to take a look at my t-shirt here. How much chance are you willing to accept? Statistics means never having to say you are certain. Well, in statistics, P is less than 0.05. I'm sure that you all recognize that little symbol there. Means the probability of finding a result by chance alone is less than 5 times in 100. Notice, by chance alone is less than 5 times in 100. This means that we could repeat or reproduce the result 95 times in 100. So if I said there's less than a 5% chance that Brian is not going to be at the airport, that means that I've worked with him to be at the airport 3 hours ahead of time. I want to be able to repeat or reproduce the effect. I want to make sure to get through the TSA on time. How much chance are you willing to accept? Well, in the real world, we do coin flipping. And with coin flipping, there's a probability of one coming up with 2 sides. And we said that in coin flipping, if I were to flip a coin 100 times, I would probably get 48 heads, 52 tails, or 48 tails, 52 heads with a little bit of error mixed in there, 50-50 chance. We know that gamblers work with probabilities. They look at what the chance is of them winning. What's the probability or the power with which they could win? What's the chance that they might lose? And also just life's oddities and chance, like the odd meeting of Brian Mendoza in the San Francisco airport. Also, I want you to think about, unfortunately, many of us have experienced cancer in our own lives or in lives of people that we know. And when those people go to the doctor says to them, there's a 75% power that this chemotherapy will work. I want you to think about, would you accept that treatment? But what if the doctor said there's only a 5% chance that that treatment will work? Will you do the treatment? And of course, in Las Vegas, people use chance. We also use probability in statistics. Researchers use probabilities. So what does this p is less than 505 mean? It is statistical significance. When something only has less than 5% chance of occurring by chance alone, then we would say that that result is statistically significant, because researchers or statistics say never having to say we're certain. So we accept that 5 times in 100 the result may be by chance alone. But if I were to do the experiment 100 times, I should expect that 95 times out of 100 I would obtain the same result again. Or you could see in my example here, if I were doing the experiment 1,000 times, I might have a p is less than 0.001, which means less than 1 time in 1,000 that this result is by chance alone. We'll go over these ideas again next week. I will solidify them with you, and I really do hope you have a wonderful weekend.